This video is on measuring centre, also known as measures of central tendency. So there are three statistics that are used to measure the centre of a dataset. We have the mean, median and mode. So the mean, we use this symbol here, the X with the line above it, of a dataset is the arithmetic average. What that means, it is the average of all the numbers, so we add them all together and divide by how many numbers we have. You'll see here I've got it in notation. This kind of weird looking E symbol means the sum of. So in this formula it's saying the sum of all the x's divided by n, which is a number of data values. So the median is the middle of an ordered data set, so we're looking for the middle of the set. So this will differ whether we have an odd or even number of values. If we have an odd number, so if our data set was 1, 2, 3, 4, 5, the median would be the middle number, which is 3. Remember with this we have to have them ordered from smallest to largest. Now if I was to add one more number, 6, our median is the middle of this data set, which the middle is between the 3 and the 4. That's where the middle is, so the median would be 3.5. We can use this little formula here, the n plus 1 divided by 2, and that will tell us the position of the median data value. So if we had 6 numbers, it would be 6 plus 1 divided by 2, which is 3.5, and so it'd be in the 3.5 position, so between the third and fourth numbers. Our mode is the most common number in a dataset, which we looked at previously. Be aware if there are two values which occur most frequently, the dataset is bimodal, which means there's two modes. If a dataset has more than two modes, we generally do not use the mode as a measure of the centre because it is unrealistic and unreliable because we have too many. Couple of examples. With these examples, we're going to find the statistics by hand, but I'm also going to show you how to do it on your graphics calculator. First example, the number of peas in a randomly selected sample of pods were, there's all the data. For this data set, find the mean, the median and the mode. Part A, find the mean. We're going to do it by hand first. Our mean is all our values added together. So 3 plus 6 plus 5. I'm not going to write all these out. I'm just going to do a dot, dot, dot here. All the way up to the last number rather than writing them all out. Divided by how many numbers we have, which in this situation is 15 numbers. This will give us 95 divided by 15. Therefore, our mean is 6.33. Part 2, the median. What we need to do is we need to order the data from smallest to largest to do this by hand. That's the data ordered from smallest to largest. We've got 15 data points, so to work out where the median is for the position, we do our how many data points, which is 15 plus 1 divided by 2, which will give us 8. So the number in the 8th position when ordered is our median. So we just count down, so 1, 2, 3, 4, 5, 6, 7, 8. So the 8th number is our median. So we can say the median equals 6. Part 3, the mode, which one occurs most often? If we look at the ordered data set right here, we can see we have 4 6s and 4 7s. Therefore, we have two modes. It is bimodal, and the mode is 6 and 7. All right, I'm going to go to the calculator now and show you how you can find your mean and median on the calculator. The mode cannot be done on the graphics calculator. You need to be able to find that one yourself. So I'm just going to head over to that now. So on our calculator, we're going to go to an Excel spreadsheet. So if you click the Home On button, it will take you to this page. And we're going to go to the Excel spreadsheet, which is the green one here. On the spreadsheet, we're just going to enter all our data into a column. It doesn't have to be in order. It can be as it has been given in the question. Once the data is entered, we are going to go to, on our calculator, the menu button. Statistics, which is the fourth one down, stat calculations, and then we only have one variable, so we're going to go to number 1, one variable statistics. How many lists do we have? We've only got one column. Every time you do this, you will only ever have one list, so just click OK. Now this is asking for all our details about our data. So X1 list is what column is our list in. Now you can name your columns, but generally that takes too much time. So what this means here with the A and the square bracket is that our data is in column A. So the A represents the column name, and then the square brackets after it is telling the calculator it's in column A. So that's where our data is. Do we have a next one down? Do we have a frequency list? No, we don't, so we leave that as 1. And the last one to look at is the result column. We just want to make sure that is not going to where our data is. Our results are going to go into column B, which is absolutely fine because we have nothing in there. Press OK, and you see here we have our data. If we go right up to the top, you see here we've got the symbol for the mean, the X with a line above it, and our mean 6.33, which is what we found previously in part A. It also tells us the next one down, the sum of all the X values, which is 95, which we also worked out. And if we scroll down, it also tells you how many data values we've got, which is 15, so our N. So you can just bring this up, it tells you the mean, and if you scroll down a bit further, you'll see here we have the median, which we also had calculated to be 6. So really quick and easy in the calculator to find all your statistics. Okay, part B. We've got a 16th pod is randomly selected and it is found to contain 9 P's. How does this affect the mean and the median? So what we're going to do is we're going to add one more data point, which means previously we had 95 for our sum. So our new mean would be 95 plus 9, because that's our new data point. And now we're going to have 16 data points. And that will give us an answer of 6.5. So it has increased our mean to rise. And we would expect our mean to rise because the value of 9 that we're adding is bigger than the current mean we have. The mean we've got is 6.33. If we're going to add a value of 9, it's only going to increase the mean. And that is what we would be expecting. Now with the median, we got to add in an extra value. So here's all our data values in order, and you can see I've just put in pink there the 9 that we've added in for the new data point. Now with the median, because we now have 16 values, the position would be 16 plus 1 divided by 2, which means our median is now going to be in the 8.5 position. So if we count along, we'll see that this 6 is in position 8, this is position 9. So it's going to be halfway between these two is our median. So the median would end up being 6.5 because it's halfway between 6 and 7. That's where the middle is. Once again, as we've added a value of 9 to the data set above where the current median was, it means we would then expect the median to also increase. On your calculator, we can also just add the extra value into the spreadsheet and it will automatically change the mean and median. We don't have to go back through all the menu options. I'll show you that quickly now. So on the calculator, if we just go to our data, and if I just add our new number in there, which is 9, what you'll see here is, if I go back up to the top, our value of the mean has automatically changed to 6.5 and our median has changed also to 6.5. What's great about this is if you make a mistake in your data entry of your information here, so for example, if this last value 9 I accidentally put in as an 8, then realised I'd made a mistake, I can just change that to 9 and I don't have to go through the whole process of going to the menu in the statistics again. It will automatically change for me. Example 2, when Caitlin proofread the first chapter of her novel, she recorded the number of errors she found on each page. The results are shown in the table. For this data set, find the mode, the median, and the mean. So the mode, really easy. We want the most common number. So we can just look at the table and you can see here, the most common number is 9. So therefore the mode would be 1 error. Part B, the median. So what we need to know is what's our total frequency, so we can work out the position. So if we add all our frequencies together, we get a value of 24. So our median position would be 24 plus 1 divided by 2, which means it would be in the 12.5 position. So what I like to do is here, I just start at the top and I start with my first 6 values are zeros. My next 9 values are all ones. So 6 plus 9 equals 15, which means the 12th and the 13th position must be within this part here, within the 1 category. So if we were to write this out, we would have had 6 zeros and then 15 nines, which is painful to write out. So I can just start with going, okay, I got 6 zeros, add the next 9 gives me 15. Therefore, the 12th and 13th numbers are in that range, therefore our median would also be 1. Now for the mean we have to do something slightly different here. Now the mean. Now when we have a frequency table for the mean, the sum of all our x values we have to do slightly differently. We can't just do 0 plus 1 plus 2 plus 3 plus 4 plus 5 because we have 6 zeros, 9 ones, 5 twos, 2 threes, 1 4 and 1 5. So the easiest way to do this is do our number of errors, in this case our first algebra is 0, multiplied by how many of them we have, which is 6, plus 1 times how many ones do we have? 9. Plus the 2 errors, how many 2 errors do we have? That's 5 and so on. So we're plus 3 times 2, plus 4 times 1, plus 5 times 1. So we are just going to our table and we're doing our number of errors multiplied by our frequency. Okay, and that's how we get our sum of all the values, and then divide that by how many we have, and we worked out when we did the median, we had 24. Put it in your calculator and we get 1.42 as our mean. Now once again, we can do this on the calculator, and especially with a group frequency table like this, the calculator means less likely to make a mistake with that top line of our mean, because all the multiplications and the additions, it's very easy to make mistakes. On our calculator, once again, go to a spreadsheet. Now in here, we're going to put our frequency table. So our first column was our number of errors, our data, which would be 0, 1, 2, 3, 4, and 5. The second column, we're going to put our frequency. So we have 6 zeros, 9, 5, 2, 1, 1. So just copy the table as it is. First column, our data. Second column, the frequency. Once we've got that in and double checked it, we're going to do the same thing we did before. So we're going to go to menu, statistics, stat calculations, and we are still going to go to one variable because our variable is the only number of errors. Frequency isn't a variable, it's just telling us how many of the variable we have. Okay, so it's still only one variable. Number of lists, we still only have one list. This will always stay the same. I've never had to change that value. Now this is where it's going to be slightly different. So the first one, X1 list, where is our data? Where are our data values? They are in column A. Okay, now do we have a frequency list? This time, yes, we do. We put that in column B. So you're going to type in B and then you're going to do the square brackets. Now you'll find the square brackets by pressing Control, the red button Control here, and the open bracket button down the bottom here. You'll see now it's in red. So Control and open bracket will give us the square brackets. Then we just want to double check our results aren't in column A or B, they're in column C, which is perfect. Okay, and now we've got our data. And so you see our mean 1.41667, which is what we found when it's rounded to 3 significant figures, 1.42. And if we go down to the median, we had our median as at 1, and you'll see here it has it as 1, 2. So you can see that way it's a much quicker way of finding our mean and median, and also less errors are more likely to occur if you use your calculator. Okay, last example. Linda has taken 4 mathematics tests so far this year. Each test has been out of 20 marks and her average mark has been 15. What mark does Linda need in the 5th test to raise her average to 16? So to start off with, we know she's done 4 tests and her average was 15. So she had 15 equals the sum of whatever the sum was divided by 4. Which means from here we can work out that the sum of her original 4 tests will be 4 times 15, which equals our sum of all the x's, So 60 equals the sum of all the x's to start with. So to start with doing 4 tests and a mean of 15, she must have got 60 overall on those 4 tests. But now we're wanting to know what she needs to get in the 5th test to get an average of 16. So we now know our mean is going to be 16 equals the sum of all the x values divided by 5. Now we need something to put in for the sum of all the x values. We know for the first 4 tests she had a sum of 60, and she's going to be adding another value to that which we are wanting to find out for the 5th test, then divide that by 5. And then from there we can just solve this to work out what x would need to be. So 16 times 5 would give us 80, so we'll end up with 80 equals 60 plus x, and therefore she would need 20 on her 5th test, so 4 marks, to be able to get an average of 16 overall. Next part of this lesson is on grouped data. So when data is presented with class intervals, we can actually only make an estimate of the mean. The reason being that if you look at this first example here, we have 10 between 50 and 100. We actually don't know where those 10 are. It could be 10 50s, it could be 10 99s, they could be all different numbers. We have no idea, which is why when we do the mean of group data, we are only making an estimate of what the mean may be. We can't be certain unless we have the original data. So let's do that for this example. So a transport department collected data regarding the distance of its trams travelled in one day. This is shown in the table. Estimate the mean distance travelled by the trams. To do this, we need to extend our table we've been given. So I've just copied it down here with our distance and our frequency. We actually now need 2 more columns. And to estimate this, what we're going to do is we are going to have the 3rd column, we are going to call it the midpoint. And then our last column will be the product. Okay, now when we're doing the midpoint, we want the midpoint of the class interval. So we want halfway between 50 and 100. You would find that to be 75. If you're not sure how to work it out, easiest way, just take the bottom end of the interval, add it to the top end, and divide by 2, and that will find the middle for you. The next one, we want the middle of 100 and 150, which would be 125. The middle of 150 to 200, 175, and the middle of 200 and 250, which would be 225. From here now, we have a similar table as what we had in example 2 here, where we have our data and frequency. But to do this, we're actually now going to be using our midpoint and frequency to work out our estimate of the mean. So the product column is just so if we're doing it by hand, we can work out it's going to be 10 times 75 to work out all the numbers that are going to go into the mean formula. We'd have 15 times 125, basically say we've got 15 125s, which is 1875, 16 175s, which is 2800, and 9 225s, which is 2025. Now we can put all those values into our mean formula because that will be our sum of all the values. So 750 plus 1875 plus 2800 plus 2025 divided by how many data points we've got, which is all our frequencies added together, which in this case would be 50. So 10 plus 15 plus 16 plus 9. And we get an answer of 149 kilometers to 3 significant figures. Now, once again, we can do this on the calculator exactly as we did example 2 in this lesson. We'll just do it again now so to remind you how to do it. Into the spreadsheet. Now, when we do our table now, we're going to enter our midpoints. We can't use class intervals, that's not going to work. So to do it on a calculator, we're going to put the midpoint, which is why the midpoint is super important to have worked out properly. Then put in our frequencies, so 10, 15, 16 and 9. So remember to put your midpoint first, your frequency second. Your frequency will always go in the B column, your data in the A column. Now let's go through those steps again. So we'll have menu, statistics, stat calculations, remember one variable because we've only got one bit of data, which is the distance. And then here, yep, our X1 list, our data is in column A, our frequency is in column B, so remember B, and then we want the square brackets, so control open bracket to get the square brackets. Results in column C, perfect, press OK. And here we go, and you'll see there, our mean is 149, which is what we just found out. And you've got all the other information here as well of things you might need. And that is the end of this video on measures of central tendency.